Here are some example problems to get you ready for the second marking period assessment. These problems span the entire year to this point. You should either try the problems or at least think through the problems to make sure you know how you would solve them. Okay, the first problem is a constant speed problem. So I want you to calculate Trevor's speed in miles per hour if he covers the 7.5 meters from red line to blue line in 36 frames. This video was shot at 30 frames per second. Assume that Trevor moved at a constant speed from the red line to the blue line. Okay, the second problem also involves Trevor, but this time he's going to be accelerating. When he reaches the red line, he's moving at about 2 meters per second. He then needs to accelerate to catch the person from the Delco Phantoms. He covers the 7.5 meters from red line to blue line in a time of 0.95 seconds. Assuming his acceleration is constant, what is that acceleration and what will his final speed be? Okay, you also have to be able to solve free fall problems. So in this case, we have a diver on a 10-meter high platform, and when they leave the platform, they will have essentially no vertical speed. Calculate how long it takes them to fall 10 meters to the water, and then calculate how fast they're going when they reach the water.
Yeah, that's right. That's right.
It's matured beautifully, and look at those long lines.
Okay, next I'd like you to find stopping distance. So this bowler's going to forget to let go of the bowling ball, and he's going to slide down the alley.
Takes off his mic, wants to be sure that everything will be perfectly in order to get these last pins, and it is a done deal. Mike Machuga has won his first ever title. Look at this! Now remember, that's not a foul because he didn't let go of it. He did it on TV, folks.
Okay, so that bowler had a mass of 75 kilograms. They were moving at 3 meters per second when they started sliding. They went down the alley 4 meters before coming to rest. I'd like you to calculate the coefficient of friction between them and the alley. Okay, in this next one, I'd like you to use forced buoyancy to find the volume submerged. Do it first for just the 4 children in the raft.
Okay, you guys, welcome aboard.
Gee, that's really big of you.
Oh, come on, Charlie Brown, we can't waste time. We've got to catch up with those bullies. Okay, Chuck, I hope you're happy now.
Okay, and then calculate the volume of the raft submerged when all 8 children are in the raft. The data you need is written on the screen. Okay, you need to be able to solve projectile problems. So sometimes the projectiles are fired horizontally, like in this example. It's fired from a height of 10 meters. It travels 22.73 meters horizontally. Find the speed with which it left the cannon. Sometimes your projectiles will be launched on an angle. So in this case, we kick a football with a speed of 10 meters per second at an angle of 50 degrees. Find the horizontal distance traveled by the ball. Assume it starts and ends at the same height. Okay, for simple circular motion, you have to be able to find the speed and acceleration of people moving in a circle. So in this case, I'd like you to do it for both TJ, the one in the blue shirt, and Sean, the one who's farther out. So as they walk, you'll notice that the person farther out needs to have a greater speed because they're covering a larger circle in the same time. Okay, next I'd like you to look at the hockey puck wrapping around the boards. Find the force required to keep it in the circular arc illustrated in this problem. Okay, you should be able to do circular friction, that is cars going around the turn. So this turn has a speed limit of 35 miles per hour, and I want to know what the sharpest turn you can go 35 miles an hour without sliding out of the turn. Assume you have average tires on a dry day and you're traveling at 35 miles an hour. You'll have to be able to do orbit problems. So try calculating the number of orbits per day that the International Space Station makes around the Earth. You can see the mass and altitude of the space station in this problem. You need to be able to do vertical forces when you're in circular motion. So find the slowest you could go around this loop without falling out of it. Use a 75 kilogram rider, and the radius of the loop when they're upside down is 10 meters. You have to be able to do roller coasters going over a hill. And in this case, the hill has a radius of 50 meters. The riders are traveling at 30 miles per hour, and I want you to find the force normal on a typical 75 kilogram rider. You should also be able to calculate number of G's. So in this case, you're at the bottom of a hill with a radius of curvature of 75 meters. Find the number of G's experienced by a 75 kilogram rider. Assume they're going 50 miles an hour. Okay, with this one, you got to find torque. So find for me the torque on this wrench. You have to be able to use torque to find balancing location. So where would you have to put this 100 gram mass to balance the 200 gram mass? You should be able to do work in power problems. So if I had a 5 Newton force applied to a 2 kilogram cart over a distance of 4 meters, you should be able to find the energy added to the car. If you know the time it took, you should also be able to find the power. Okay, kinetic energy. You should be able to find the kinetic energy of an object, and you should also be able to find the kinetic energy lost, or the percent of kinetic energy lost. So in this case, we have a hockey puck hitting the boards and slowing down. It went from 25 meters per second to 15 meters per second. The puck had a mass of 150 grams. Find the percent of its kinetic energy lost. You should be able to calculate the potential energy due to gravity. So here I hold the baseball at the top of the school gym, which is a height of 9.5 meters. Calculate its potential energy before I let go. You should be able to calculate elastic energy. So find the elastic energy stored in this slingshot. The spring constant's 500. The stretch is 1.5 meters. You should be able to use energy along with energy conservation to find things like speed of launch and maximum height. So here we take elastic energy, we turn it into kinetic energy, and then turn it into potential energy, gravity. You should be able to impulse impulse and momentum. So here Claude Giroux is going to give an impulse to the puck. Use your impulse formula to find the impulse and also the final speed of the puck. You should be able to do conservation of momentum. So here a 1,000 gram cart is going to hit a 500 gram cart. Before the collision, the 1 kilogram cart was moving at half a meter per second. Afterward, it slowed to 0.25 meters per second. Find the speed of the lighter cart after the collision. Okay, so if you are able to do those problems, you should be in good shape for your marking period assessment.